Yes, hello. My name is Abir, and I'm going to show you one of the projects I did this summer. So I was doing my internship in Stefan's team, and especially I was working with the Faroe AI guys, so Sebas and Alex. But Sebas was my tutor. So what I'm presenting today, it's called edit distance, and it's a way of measuring the similarity between two strings. And obviously, strings can be similar even if they are not exactly the same. So one of the application of this project is the autocorrection. So when you write a word, sometimes you mistype it, and the computer by magic shows you a potential noun. And how it does, it calculates actually the word the closest of the one you typed, and yes, one other application is the duplicate code detection. Sometimes you copy paste some code you found, and it happens that sometimes you already have this one in your program. And the code is actually exactly the same. The two methods do the same thing, but sometimes you have like space characters, and you have like here when you can see, and the second method you have a dot, and the first one it's missing. So yes, it detects these errors. And this project actually doesn't work only with in the computer science field. It's also necessary for doctors or biologists. Because, for example, in COVID, we didn't have only corona, we also heard about variants. And so how the doctors or researchers end up with this conclusion. So they only took the DNA of the virus, for example, corona, and they took the DNA of the new variant, the unknown, they didn't know where it came from. And so they just aligned the two strings. And since DNA string is represented with the characters, so they just align it and see how similar they are. And if they are similar enough, we can expect them to have same functions. So if COVID gave you like flu or whatever, so the variant will have the same symptoms. So now, what is edit distance in simple words? It's how many edits we must do to transform one string to another. So we have a simple example there. For example, you wrote Zork. It doesn't make any sense, but you wanted to write fork. It makes a sense. So the only thing that you have to do is to do an edit, to edit your sadly mistake. And so what you have to do is you have to substitute the first letter with the second letter. So you have to substitute Z with F. So you did one edit. Now, how many edits or how many operations we have? Well, we have 4. We have insertion. So you want to add the letters that are missing, or you want to delete some letters that are additional, or you want to substitute, as you saw before. And also we have another example there. I'm going to explain you on the example. So for example, you want to go from the first string, which is a cat, and you want to transform it into an act. So you can see that to go from the first to the second, we have to add an N because we don't have it. So it's the green highlighted character. So here we did the one insertion. So we have an edit distance of 1. Now we see that we have CA letters, but they are swapped. So we can just swap them or transpose them, and we can have the final string, which is an act. So the two letters are the highlighted purple letters. And we did the first operation, which is transposition. So in total, we have an edit distance of 2. Now, how it is implemented. To calculate this distance, we use a matrix, but we call it a distance matrix because the matrix is just a table that shows us the distance between two pairs of objects, so strings, whatever. So in our case, I don't know if you see. Yes, you see. So in the first row, you have the final string that you saw before. So an act. So we have it here. And on the first column, we have our first string that we want to transform, so a cat. So if you can see, for example, if we take only the first letter of each string, so let's say we have the first string, which is A, and the second string, which is A. So we want to go from the first to the second. We don't have to do any edits because actually it's the same letter. So the edit distance, it's 0. You can see, yes, the 0. And if, I don't know, for example, you want to go, well, actually, each cell, once you go through the matrix, you calculate the distance between the two strings. And finally, in the last cell, in the green one, you can see the edit distance between your first string and your second string. The implementation, or I would say like the algorithms, it's pretty much complicated to explain, but I have a blog post that I can show you later. And so how to use it is actually very, very simple. You just create an object with the class. So here you can see that the class is named AI Damero-Levenstein distance, because we don't have only one edit distance. Well, we have a lot of algorithms that allow us to measure similarity. We have, for example, a Hamming distance. I think you know it. We have this one, Damero-Levenstein distance. We have other ones. So I implemented 2, and one of them is this one. And so you only have to use the method, which is distance between, and you take your first string and your second string, and you print it, and you have the distance. So it's very easy to use. And yes, I didn't explain actually how the algorithm works, because I already explained it once and nobody understood, or it took me like 1 hour. So if you want to understand it, because to be honest, I had really tough time to understand it. It took me like half of my brain, and so I rewrite a blog post, and it's really cool, I guess, and it's really like understandable. So here's the link if you want. And yes, thank you for your attention, and that's it.